Try it again. All right, so for today, what we're going to be doing is we're identifying parts of the expression. We're going to simplify expressions by combining like terms and using distributive property as well. So this is the idea of an algebraic expression. What we have considered here, this portion is our first term. So we have it where terms are going to split things up. They're going to be a number, a variable, a product, or a quotient of numbers and variables. They're always going to be separated out. If you've got more than one term, they're going to be separated by addition or subtraction signs. So I'm going to go ahead and highlight term in our orange real quickly. And if you don't have your colors out by now, don't waste time getting them. Our second term is going to be not just the 2, but the plus 2. The entire thing is considered to be the second term. Okay, the operation in front of it is included in the term. When we talk about a coefficient is going to be the number that is attached to your variable. The reason that it's attached is because it is a multiplication portion. So it's just this value 6. 6 is the only part that is considered to be the coefficient, not the x. So a lot of times when I ask students, hey, what's the coefficient? They say 6x instead of just the 6. The x is not a coefficient. What is the x called, guys? The variable. Your x is a variable. The coefficient is what your variable is being multiplied by. Every variable has a coefficient. Remember, if the coefficient is not written there, then that just means that the coefficient is an invisible 1. Okay? So our variable is the x, the letter. And it's representing an unknown value, a value that we are not sure of. It could be any value depending on our situations. Then we have our constant. Our constant is a number that is added or subtracted in your algebraic expression. So again, it's not just the 2, but it's the plus 2. It's important that you include the operation with it. Okay? You have to include that it's a plus 2 or a minus 2, because when you separate them by term, that plus sign is indicating that the 2 is positive. If it had said minus 2, then the term would be a negative. So I'm going to do one example with you, and then you're going to do example number 2 on your own. We're just going to identify our terms, our coefficients, our variables, and our constants for each of the linear expressions provided. So let's take a look at the first problem. We have 8x minus 4. So our terms, again, they are separated by addition or subtraction signs. So our first term is the entire quantity of 8x. I'm going to put a semicolon to show a separation for my second term. My second term is negative 4. I must include that minus sign with it. Coefficients. The only coefficient I have is the 8. 8 is going to be my coefficient for this problem. It is the only number value attached to the variable. The variable that I have in this situation, I only have a single variable, and that is the letter x. And then the constant that I have, the constant is the minus 4 or the negative 4. Again, you must include the operation that is in front of it. I want you guys to go ahead and do problem number 2 on your own. Okay, let's go through this. The terms, who can tell me what are our terms for this problem? Richard? Good. All right, we've got 3, negative 2x, 9, 7y, and negative 13. Those are all considered to be terms for that expression. What about the did you have a question, Mario? No, you want to answer the next one? All right, so coefficients then, Mario. What's the coefficients? Negative 2 and a positive 7. Those are going to be our coefficients for the problem. Okay, what about our variables? What are those going to be, Amy? I'm sorry, Asia? Asia, yeah? Those are semicolons. So a comma, we don't typically use commas to separate problems out in, or responses out in math, only because a comma is part of a number, isn't it? Like if you've got a number that is more than the hundreds, if you've got 1,000, then you use a comma to separate in that. So you don't use commas to separate your numbers out. You use semicolon to separate data points out. Okay? Variables, what are our variables, Montserrat? X and Y. We have both an X and we have a Y. Okay, and then our constants, the values that are constants, Fatima?
3, 5, and 13.
Not just 13. Negative 13. Don't forget that negative sign. Okay, 3, 9, and negative 13. Those are going to be our constants. Okay, so it's important to understand what our variables are, what our coefficients are, what our constants are, especially when we are getting into combining our like terms. So go ahead and flip your paper on over to the back. So here on the back, what I want you guys to do is you're going to identify the like terms. So again, like terms are terms that have a common variable that is raised to the same power, meaning an exponent. So if you have x and x squared are not like terms. Let's write that up here at the top. If you have something like x and x squared, these are not like terms. Because again, it must be raised to the same exponent, the same power. The value of x is not going to be the same thing as the value of x squared. Okay, so you have to understand those like terms cannot be, or those terms cannot be combined together. They are not alike. Just the same as x and y cannot be combined together because they are different variable representations. Just the same as 5 and x cannot be combined together. One of them is a constant and one of them is a variable. Okay, so you have to understand the differences between variables of the same term versus not. Okay, so I want you guys to go ahead and highlight when we're talking about our like terms. Okay, they have to have a common variable and they have to be raised to the same power. They can also be constants. Simple numbers are like terms to each other. Okay, so numbers can be considered like terms. So if we were to start with the number 7 or the term 7, who can tell me what value up here would also be considered a like term to the value 7? Logan? Negative 8. So 7 and negative 8 are considered to be like terms because of the fact that they both are constants. Let's write that down. 7 and negative 8 are like terms. And I'll put in parentheses, they are both constants. Seven and negative 8 are like terms because they are both considered to be constants. Okay, let's go on to another term. Let's talk about 4x. 4x has a like term with what? Kai? negative 1/2 x. Okay, so negative 1/2 x and 4x are considered to be like terms. Okay, and the reason for that is because they both are in term of x. Alright, and then our last set that we have here, I'll just go ahead and do that myself. We have negative 2y and a 0.6y. Those are also considered to be like terms because they're both terms of y. Now it's important to know what your like terms are because when you are simplifying an expression, you simplify by combining your like terms together. If an expression can be simplified, it's typically because you've got several like terms that you can combine together to shorten your expression. So for here, problem number 1, we've got 4x plus 3x. Yesterday we talked about the fact that when you're combining variable terms together, you're really just combining the coefficient together and you're keeping the variable whatever it is. So in this case, 4x plus 3x means that we're really just combining the 4 and the 3 together, which gives us 7. And then we keep the x connected to it. So that would give us 7x as our answer. Sometimes you might have other parts or other terms that don't have a like partner with it, and therefore you can't simplify or combine that with anything. But for problem number 2, again, we do have the 3x and the negative 8x that can be combined together. So I can rewrite this because remember, we can change this. This technically is the same as saying plus and negative 8x through that additive inverse, right? You can add the opposite instead of just doing subtraction. And then addition lets us know that we can change the order, right? Instead of saying 3x plus 6 minus the 8x, I can actually rewrite it as 3x minus the 8x. I can rewrite that because I've got an addition in there, okay? So that's allowing me to use my commutative property. So knowing our properties allows us to rewrite so that we can have like terms side by side to focus on, and then whatever's not a like term can be pushed off to the side, like that plus 6. That plus 6 is not considered a like term, so I'm just going to write it off to the side here. Then I combine what I can. I can do 3x minus 8x. I'm technically just doing 3 minus the 8 and then keeping the x with it. What's 3x minus 8x going to give me? Negative 5x. You got to know your difference between your positives and your negatives. So we get a negative 5x, and then that plus 6 just comes straight down. And there's our final answer. Negative 5x plus 6. I want you guys to go ahead and do problems 3 through 6 on your own, combining like terms and simplifying it so that you have only one of each type of variable, because there might be more than one variable, and only one constant if there is one. All right, let's go over this real quickly. So for problem number 3, we have negative 2y plus 4x plus 2x plus 7y. I'm going to go ahead and identify my like variables. Now here's something that you need to understand as well. When you are putting an expression down, it is always appropriate to go in alphabetical order, and then the ending should always be a constant. You always start in alphabetical order. So we have two variables. We have a y and we have an x. Which one should I start with first if I'm going in alphabetical order? X. Whew, Lucas. X. We need to go with the x's first. So we're going to start with our positive 4x and a positive 2x. That's what I'm going to focus on first. So I'm working with the expression 4x plus 2x, which is going to give me 6x. And then I'll work with the y's. So I have a negative 2y plus 7y. So negative 2y plus 7y. That's going to come out to a positive, so notice I'm writing a plus sign, a positive 5y. You need to make sure that you write your plus and minus signs when it's a second or third or fourth part in an expression. Obviously, you do not need to write the plus sign if it's the first term in the expression. But this would be our simplified expression right here. Okay? For problem number 4, we have n minus 4 minus 9n plus 7. So we only have one variable that we're focusing on, which is the value n. So we have n and a minus 9n. I'm going to write those together. Now, I'm not just going to put an n because I want to make sure I understand again that there is what in front of it, Fatima? A 1. There's that invisible 1 that's right in front of that 1n. And then I have that minus 9n. So I'm doing 1n minus 9n. That's going to come out to a negative 8n. Then I can focus on the constants that I have. I have a negative 4 and a positive 7. So a negative 4 plus 7 is going to come out to a positive 3. So you should get negative 8n plus 3. Okay, for problem 5, we've got negative 3x minus 9 plus 15x minus 2. So we only have one set of variable terms. I'm going to focus on those first. Negative 3x plus the 15x. Negative 3x plus 15x. That's going to come out to a positive 12x. I don't have to write the positive sign because it's the first term that I'm writing. Then we just have constants. We have a negative 9 and a negative 2. So negative 9 minus the 2 is going to come out to a negative 11. So there's our expression, 12x minus 11. All right, problem 6. We have multiple different kinds of variables. So which variable do I focus on first? Somebody new. Lucas.
X.
The x. Very good. So my x terms are going to be negative 11x and a positive 11x. So if I've got a negative 11x plus 11x, what does that come out to, Richard? A 0 pair. Very good. I'm glad you used that term too. You get a bonus point in here for today. 0 pair. It's creating a 0 pair, which means it's zeroed out. It's not going to be there. I can write 0x, and I'm going to put a little slash through it so you know that this is a 0. But there's no reason for me to write it. When my expression is simplified, if it is a value of 0, because we know, based off of the multiplicative identity of 0, that anything that you multiply by 0 is just 0. So I don't even have to write the 0x anymore. I'm just going to go ahead and not have it written when I simplify further. Okay? The next one that I'm going to focus on is my y's. So we're going to focus on 7y minus the 8y. So we have 7y minus 8y. That's going to come out to a negative 1y. And then we've got our positive 12 that we don't have anything to combine with. So we just write positive 12 or plus 12. So when I write my simplified expression, I don't need to write the x. I also don't need to write the 1, but I do need to write the negative sign. So when you see it as an answer, it's actually going to be written as negative y plus 12. That would be the official format that they would write as an answer on a test or a quiz or on an assignment. What would be accepted? When you have a 1, you don't have to write the 1. But if you have a negative, you have to write the negative. Okay, any questions? All right, so what you're going to do right now, you are going to get to work with a partner. You can work with a partner. You're going to complete these 6. And when you are finished with those 6, you are then going to come up and you're going to check it with my copy. I'm going to have 2 copies that you're going to be able to look off of. So that way you can just send one of you up to check it. Only one person has to come up to check. If it's correct, then you guys will then log in to your Google Classroom where there's going to be a Google Slides assignment that you need to complete. Okay? The Google Slides assignment is an independent assignment. This is the only thing that you're working side by side with a partner on. Any questions?
Oh,
Yes,
how come I don't get on?
you may.